In part one of the career path investigation, the doctor looked at two different data model frameworks, the data analytics maturity model and the 4-quadrant model. The doctor found that the 4-quadrant model provided a much more robust and granular data model on which to analyze potential career paths. In this second part of the discussion, we'll use examples of HR activities in the 4-quadrant model and simple visualization to assess technical skill requirements. The model framework assessment in part 1 resulted in a set of example HR activities clustered into 4 groups or quadrants and differentiated by 2 measurement dimensions: analytical sophistication and value returned to the organization. To assess the technical skills needed to operate in all 4 quadrants, we selected 3 very common data analytics tools and mapped them against HR activities in the value matrix. Spreadsheet tools, like Excel, have broad mathematical and some statistical capabilities. Cross-sectional regression includes basic regression analysis through diagnostic regression that's used to identify potential outcome drivers. And finally, time series regression incorporates predictive and prescriptive modeling plus scenario development. These 3 example tools represent increasing levels of data analytics competence that will be mapped to the example HR activities in our value matrix. Spreadsheet tools like Excel are very prevalent in the compensation and HR professionals toolkit. These tools are very flexible and they incorporate a broad range of computational complexity. And most organizations have practitioners with widely varying expertise that may provide mentoring. Example milestones in the learning curve graphic are intended to provide a reference for your own personal assessment of current Excel skills. The milestones are not exhaustive, and no, the arrow is not drawn to scale. Cross-sectional regression measures statistical cross-variable relationships, typically within a single point in time. In the HR space, correlation and cross-sectional regression analysis are used to identify outcome drivers like the drivers behind pay equity in an organization. These are skill sets that are not highly prevalent for most compensation professionals. Basic regression modeling starts with single variable regression and extends through cross-sectional analytics. The learning curve graphic identifies key milestones to achieve in ramping up that basic regression modeling knowledge curve. Notice that the doctor does not consider naive curve fitting, the current state for pay structure development for most compensation professionals and market pricing software vendors, to be part of basic regression modeling. Naive curve fitting worships at the foot of R-squared, which is just one factor in evaluation of good regression models. For practitioners who need to operate at this level, there is much to learn. Time series regression incorporates, well, time into regression statistical analysis, and time, as it progresses, has the pesky habit of changing relationships between variables. So this level of regression capability is quite challenging. Most predictive modeling requires time series analysis. This is not a skill set resident in most compensation or HR departments. Time series regression starts with understanding the shape and the sign of relationships between variables, and it then progresses through model building and implementation. The learning curve graphic shows key milestones in knowledge development. Time series modeling is among the most sophisticated analytics used in the HR space. Okay, now that we've suggested in the last 2 screens that transitioning to HR analytics will be very hard, let's assess each of these activities on the value map and identify, based on experience, the best analytical tool. All of the Q3 activities, circled in blue, are best analyzed using spreadsheet capabilities like Excel. Ditto for Quadrant 4. The HR activities best analyzed using cross-sectional regression are outlined in yellow. Specialized commercial statistical software can be used to analyze these activities, but the Excel Data Analyst add-in is also a very capable alternative. HR activities circled in purple require time series analysis, which does require specialized commercial statistical software. Excel has very limited capabilities for this type of analysis. Now let's add some simple graphics, block arrows, to represent applicability, scope, and flexibility for each of the tools. The arrow width suggests use case flexibility, length indicates scope, and dark shading identifies broad applicability. Spreadsheets require less analytical sophistication but provide returns across the organization value spectrum, and they have several inherent advantages. First, very broad applicability for HR activities in both Quadrant 3 and the high value, low hanging fruit in Quadrant 4. Spreadsheet tools can also work independently from and do not require investment or training in data management systems. And finally, from a management perspective, spreadsheet analysis using tools like Excel have greater familiarity for executive decision makers and typically higher credibility than more arcane tools. Cross-sectional regression, depending on management and regulatory focus, sits squarely in Quadrant 1, but also could be in Quadrant 2. This type of analysis requires specialized training. Commercial tools like SAS or the R programming language are certainly appropriate tools, but Excel's Data Analyst add-in is also a perfectly reasonable analytical tool. Time series regression and predictive modeling resides in Quadrant 2. It's the most difficult from an analytical perspective, but it produces very high return to the organization. Operating at this level requires significant skill set development and experience. Commercial software like SAS or R are appropriate tools for this level of analysis. Spreadsheets do not have the data management or statistical capabilities to take on these tasks, particularly on a large scale. So in part 2 of our investigation, are there any insights? Spreadsheet tools like Excel are very flexible, powerful, and have broad applicability across the HR activities value spectrum. Compensation professionals, therefore, can envision the transition to HR analytics fairly early in their careers. And while there are specialized skills in compensation that must be developed, determining pay equity drivers is a very good example, those skills can be developed as part of a natural progression within the compensation role. Continuous improvement in Excel skills is a must, but shifting gears to learn a new commercial software tool or becoming an R code slinger is certainly not a short-term necessity. The Data Doctor has used the data analytics process and basic visualization to illustrate that technical skill requirements subdivide into 3 broad areas of expertise, and that these skill areas correlate with role and career level. We hope this data-driven storytelling may provide ideas for your own analytics, investigations, and communication. The next blog will convert the data-driven analysis in parts 1 and 2 into a career path transition that compensation professionals can use to plot their own career development.